Today's lesson is going to be on speed and velocity, so the difference between the two, and we're going to be doing that by looking at Iron Man and Rainbow Dash from My Little Pony, and to see who would win in a race. So Rainbow Dash versus Iron Man, to learn about speed and velocity. So you're probably already quite familiar with what speed is, or you have an idea of it, or you've at least heard of it a million times. Speed is how fast something is moving. Now velocity isn't much different, to be brutally honest, but you are going to need to know the difference for that exam. It's very easy actually, the difference. So speed is how fast something is moving. Velocity is speed in a given direction. So if I know the direction of something and I know how fast it's going, I know the velocity. So the velocity is composed of two numbers really. It's composed of the speed and the direction in which you are moving. So if you look at Rainbow Dash here on the right, we have Applejack, the My Little Pony, saying Rainbow Dash is going at 118 miles per hour southeast. We know her velocity. She's going in the direction southeast and her speed is 118 miles per hour. If we look on the left-hand side, Black Widow is saying that Iron Man is going at 120 miles per hour, but we can't see him. So we don't know the direction he's going in. We only know his speed. So speed is how fast something is moving. Velocity is speed in a given direction. The top speed is the maximum speed that an object can move at, and the maximum or top speed will vary depending on what the object is. A car's maximum top speed will be much higher than a human's, for example, and then a human's will be more than a snail. But we don't often talk about top speed. We talk about something called average speed, and that is going to be the focus of today, and I need you to know the difference between the two. Top speed is the maximum speed that an object can move at. Right, this is the main slide. This is the slide that if you take nothing else in, this is the one that I want you to get in for this lesson. It's going to be a long slide. Bear with me. I'm going to go right back to the basics so that those people with no knowledge of maths, no knowledge of GCSE or Key Stage 3 physics can get this, okay? We don't run or drive around at top speed all the time. On your journey to the shops, you don't sprint the whole way. So let's think of you driving a car on a racetrack. At bends, you might go a bit slow. At the beginning, you'll be speeding up from that start line. Your speed may change slightly as you try to take over somebody or you change gears. And because your speed is changing slightly, we tend to talk about average speed. This is sort of like your middle speed in the race. Not you at your fastest, not your top speed, but similarly, not your slowest. So an average is like the middle number. We can take the average of lots of things. If you took the average height of everyone in your family, it would be a height roughly in the middle of you all. If you took the average salary, the average amount that a doctor earns every year, you'd get a number roughly in the middle. You wouldn't be seeing the highest earning surgeon or somebody fresh out of school who's just started to be a doctor. The average would be somewhere in the middle. And the same is for speed. The average speed is that, somewhere in the middle. We can work out the average speed in physics with a little bit of easy maths and what we call a formula. And trust me, it really is easy. Formulas are great. They're like little toolkits or instructions for finding out useful things. In front of you right now is a formula to find average speed. It's in the green box. Remember, not top speed, average speed. The formula, as you'll probably see it in an exam, would be written as S equals D, then a line T. Each of the letters in the formula stands for a word which I've written below. Speed equals distance divided by time. S equals D divided by T. Now you may not have seen the divide symbol written like this. When we get to maths at a higher level, we almost never see the traditional divide sign. You know, that line with the two dots above and below it. I challenge you to look up any complicated maths by Einstein, etc., and see if you can find a traditional divide symbol, and I'd be shocked if you did. And it's because when we get a little bit higher in maths, we don't use it, we use a line. You might be surprised to know that the line between numbers in a fraction is also a divide symbol. So if you divide the two numbers in a fraction, you get the same number, the same value of that fraction, but just in a different form, which we call a decimal form. Anyway, so speed equals distance divided by time, s equals d divided by t, is written like this with a line. The line may be a slash symbol like I've put there, but it also might be a horizontal line that you would see in a fraction. Right, so now we know that the line is a divide symbol. The formula. Physics is all about formulas, and most of them will have division in them, and the division will be shown by a line. Formulas are really fun and so incredibly useful in all avenues of life. Please don't be scared of them, because once you understand them and you get them and you can use them, you will ace this GCSE, I promise. Formulas are really great because they can be rearranged to find out all the things in them. So looking at this formula now, speed equals distance divided by time. With this formula, I can work out the time I took in a race, the speed I travelled at the race, and the distance that I travelled. But in order to work out any of these things, I need to know the other two. That's the restriction of the formula. In order to work out one part of that formula, I need to know the other numbers to plug in. So to work out my average speed, s, I would need to know the distance I travelled and the time it took. To work out the time it took, I would need to know the distance travelled and the speed I went at. And then similarly, if I wanted to know the distance that I travelled in a race, I'd need to know my average speed and the time I took. And this is where this handy picture comes in. We call it the speed, distance, time triangle, okay? Remember when I said that horizontal line means divide? Well, that's exactly what's happening here. Look at the three triangles on the right-hand side. The orange part is the thing that we want to know in each of them. So if we look at the bottom one, we're trying to work out what the speed is, the average speed. So what you do with this triangle is you cover the letter S, you cover the speed, you cover the thing that's in orange with your hand, and what you're left with is a D over a T, a D with a horizontal line over a T. And we know that that line means divide, so it's distance divided by time. So to work out the speed, I cover up the S on the triangle and it leaves me with the distance divided by the time. If I move up one, if I wanted to know the time taken in the race, I'd cover up T and I'm left with distance divided by speed. If I want to know the distance travelled, I cover it up again on the triangle and I'm left with speed multiplied by time. So just for this triangle's sake, when something is next to each other, it's multiplied. Now, I hope you got that. I tried to go right back to the basics for those of you with no previous knowledge, but if you didn't, I'm putting up some Facebook videos now, because you really need to know this formula. This is the thing that this lesson is all about. So if you don't understand it, I would learn it now. Do not wait. So you've probably all heard of someone called Usain Bolt. He is considered the fastest human of our time, and he holds the world record for both the 100-metre and the 200-metre sprint. When we say he holds the world record, we don't really talk about his top speed. What we're talking about is his average speed, the one that we've just been learning about in that formula. So he's run the 100-metre race, and we've taken the average speed over that 100 metres, and we've done the same for the 200-metre sprint. So you know the distance he's travelled. He's travelled 100 metres, or 200 metres, depending on the race. You know the time that he took, because somebody stood there, well, not somebody stood there, you know, a machine did it essentially, but a stop clock took his time when it started at the beginning, and then when he passed that finish line it stopped. So we know the time he took to complete the race, and we know the distance that he ran in that race. So I would like you to work out the average speed. Now we're going to work it out together with the 100-meter sprint, and then I would like you to have a go on your own with the 200-meter sprint. So to work out the average speed of Usain Bolt in the 100-meter sprint world record, we use the formula speed equals distance divided by time. So what we do is we plug it in. We replace those words with the numbers. So speed equals the distance. So instead of writing distance, we rub that out and we put 100 because it's 100 meters. Divided by, we put that line back in. And instead of time, we write the time that it took. And he did it in 9.58 seconds. So we now have a little bit of maths in front of us. We have speed equals 100 divided by 9.58. Now, if you did that with a calculator, what you would get is 10.44. So his average speed is 10.44. But 10.4 for what? And this is where the importance of units comes in. And this could scupper you in an exam, so I recommend you just spend a bit of time getting used to this. The units of the result, the units of the speed, have to be the same as the units that you plugged in the first place. So you plugged in meters, 100 meters, and he did it in 9.58 seconds. So he ran 100 meters in 9.58 seconds. So we merged those two units together, meter and seconds, and the speed he went is meters per second. This is probably the one that you're going to get the most of in your GCSE exam, meters per second. I've put the little notation up there in the right hand corner. It's m/s, meters per second. You might get miles per hour, you might get kilometers per hour, much more rare. In physics, we generally talk about things in meters per second. So we use that formula, speed equals distance divided by time. We plugged in our numbers for the 100-meter sprint, and we found out Usain's average speed for that race, which was 10.44 meters per second, which means every second he ran 10.44 meters, which is pretty insane, to be brutally honest. What I would like you to do now is pause the video and have a go at the 200-meter sprint. Okay, so you're going to just plug those numbers into that formula. The average speed equals the distance divided by the time. The distance in meters divided by the time in seconds. Have a go, pause the video, and we'll move on. So hopefully you've had a go at that, and you've probably or hopefully come up with something similar to what I have here. You plugged in the numbers. It was 200 meters in distance, and he did it in 19.19 or 19.19 seconds. If we actually do that, if we divide 200 by 19.19, we get 10.42. And we get that to 2 decimal places. If you don't know how to work with decimal places, then you need to look at our video that's in the pre-GCSE folder, okay? They're crucial. You need to know the difference between decimal places and significant figures. And I asked you to do this to decimal places, 2 decimal places. So 200 divided by 19.19 equals 10.42. And the units would be 10.42 meters per second. Usain Bolt completed the 200-meter sprint in 10.42 seconds, which, to be honest, isn't much different from the 100-meter sprint. He did it slightly slower average speed than in the 100-meter sprint. So I just spoke to you about units, but I really want you to really take in how important this is. I've worked in research with degree students, PhD students, even university lecturers who still get units wrong, and they will lose you marks in your exam if you don't look at them, okay? I'm going to talk about units almost every lesson. So this lesson, I will just focus on the units that are of importance to this formula, speed equals distance divided by time. So when we're trying to work out the speed, we need to know the distance that you travelled and the time it took. These two are measurements in themselves. We normally measure distance in miles or meters or kilometers, and we normally measure time in things like hours and minutes and seconds. So it is more than possible that you could be presented with an exam question that asks you to find out the average speed, but gives you these distances and times to plug into your equation, to plug into your formula with different units. They may give you the distance in miles. They may say Tom drove 10 miles, and they may give you the time in minutes. So they may say Tom drove 10 miles in 5 minutes. If you just plugged those numbers into the formula as is, you have to remember that the answer you get, the units of that answer have to match the units that you put in. So you'd get Tom went at a speed of whatever miles per minute. Similarly, if they gave you the unit of distance in kilometers and then the unit of time in seconds, the answer you're going to get, the average speed you're going to get, is in kilometers per second. Now, you don't have to learn them all. It's pretty simple when you think about it that way, but what we normally use in physics is meters per second. The annotation is again there, it's in yellowed, highlighted, m/s, meters per second. Most of the time you're going to get that. So if you're going to do practicing, I would practice focusing around that, meters per second. And that's going to apply if you continue to do physics in a degree and in your career. Most of the time you'll be working with meters per second. So it's good to get used to that now. However, look, because it's not absolutely definite that your exam question will be in meters per second. They have done it in miles per hour before, and they have done it in kilometers per hour before. I've never seen it written in meters per minute or anything else, but do look out, okay? You're going to have to make sure that the units that went in are the same as the units that come out of the formula. This is a practical that you're going to need to learn sort of theoretically, more from a book, for your iGCSE, because it's very likely that you could get tested on it. You're not requested to do it. Of course you can do it, and we'll go through a way you can do it a bit later, but you do need to know how you would do it, even if you don't actually carry it out. So they do shake it up a little bit. They very rarely actually give you exactly the same experiment every time, which makes it a little bit harder for you, but the same principle will apply each time. So if you learn a little bit of the equipment that's involved and you learn essentially what's going on, you should be able to recognize it in an exam and then answer the questions correctly or accordingly. So essentially what's happening here is you are trying to put the formula speed equals distance divided by time into action. So what you've got is a ramp, and then you've got a toy car placed on that ramp at the same place every time. Remember, we need a fair test, and we're going to drop that car down the ramp, and these light gates are going to recognize at what time that car passes through them. So every one of these experiments must have at least 2 light gates or a similar thing. We'll talk a little bit more about light gates in a minute. So this car is going to go through this first light gate, and the light gate is going to record the time. It's going to carry on going down the ramp, and the second light gate will also record the time. So we now know the time that it's gone through 2 light gates. From this, we can work out how long it took to travel between the two.
So if we pass through the second light gate 1 second after we pass through the first, we knew that it took 1 second to pass between the two. Now remember, when you have speed equals distance divided by time, you need 2 of the components of the formula to find the other one. So if you want to find out speed, then you're going to need to know the distance and the time in order to find that out. And that's probably what they're going to ask you, to find out the average speed. So the light gates are going to feed us with the information to know the timings of the car moving through it. And then the distance is quite simple. We just get a tape measure and we can measure the distance between the two light gates. Now this experiment has 3 light gates, so this has made it a little bit more interesting, because not only can we calculate the speed between the first 2 light gates, we can also calculate the speed between the second 2. Oh, and we could compare them, so we could see whether the car's average speed is different at different points on the ramp. In your exam, what you're going to need to know is some of these key pieces of apparatus, key pieces of equipment. Sometimes we call equipment apparatus. A light gate is one of them. It's like a sensor. It's recognizing when the car is passing through it. But it's almost useless on its own. It needs something called a data logger. You will encounter a data logger quite a lot in physics. It's basically like a computer screen for your light gate. So your light gate is the sensor that's recognizing the time that the car passes through, and your data logger is sort of showing you on the screen the time. So light gate and data logger are 2 pieces of equipment that you need to be familiar with. If they ask you to write out an experiment that's going to test speed equals distance divided by time, they would definitely give you a mark for writing about light gates, and possibly writing about a data logger as well. The experiment can be shaken up a little bit. The ramp may be a different angle, might be steeper. They might not use a toy car, and they might not use light gates. They might use something slightly less sophisticated, simply like a stopwatch and the human eye. But obviously there are going to be limitations to that. It's not going to be as accurate. Which brings me to my next point. Every time you get asked about a practical in an exam, it is a prime opportunity for them to ask you not even anything about the specific experiment, but to ask you some questions about experiments in general. They want to know that you know how to carry out a practical well, because that's what we're training you to be. We're training you to be a scientist. And you could do this little ramp experiment a million different ways, and none of the results that you produced would be any good. So some of the tips, some of the things that they're going to be looking for is using good apparatus, using good equipment. So like I said, things like a data logger, things like a light gate, they're going to be really good apparatus. They're electronic. They're going to give you some really accurate answers. They're not just going to sort of give you seconds. They could give you things to milliseconds and even more detailed. They do have their limitations. You'd have to reset them. You have to make sure they're working, things like that. But generally, that's a good apparatus. You need to have logical methods. If you're writing out a method, it needs to be in order, it needs to make sense, and it needs to be really clear. A fair test. They might ask you how something would be a fair test. A fair test would be, say I wanted to find the speed on the ramp of 3 different toy cars. A really good example of a fair test would be those toy cars all need to start at the same start line. Okay, if one's starting a bit lower down, it's not really a fair test, is it? It's gonna go through the light gates quicker, and especially in this one because it's already started past the first light gate, or it might not even register on the first light gate at all. So they definitely ask you things about a fair test. So there are lots of different things you could think of. Hopefully you've thought of a few more in there. The biggie that they seem to love for some reason is making reliable results, okay? In science, you don't just do an experiment once. The only time you would do an experiment once is if it was so difficult and so expensive to do that just doing it the once was a great achievement, a challenge enough. You know, generally every experiment must be repeated. And this is really crucial for this lesson actually, because we're talking about averages. If I repeat a experiment several times, the results that I get from that, I understand, are going to be more reliable than if I do it once and just for some fluke reason something happens and the car goes through really quick. We call it an anomaly, and when we repeat it, we can remove that, so we know that the results are more reliable. So if it asks you how could you make the results more reliable, you repeat, 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 repeat. If you have any worries about writing some of the answers or being questioned on some of these more sort of generic questions relating to practicals in general or experiments in general, then I do go through how to make a good experiment in the pre-GCSE prep videos. So you can go through them, you don't need to worry. If you want to try an experiment like this at home, please do. You can raise absolutely anything you want. You can make a ramp at any angle that you want. You can do different things. You can test different things. That's the great thing about science. And you can experiment with trying to make a really good experiment using that pre GCSE lesson on making a good experiment. You can actually put that into action. So you can think about what's really good apparatus, what's really good equipment, what's really reliable. How am I going to repeat this lots of times? And is my equipment going to be good? So I've done an example here. It's exactly the same. I've chosen fruit rolling down a ramp as a fair test. I've made sure that they all start at the same start line, but obviously you can choose whatever you want. And try and do some of the formula. Try and see if you can work out the average speed of whatever you're racing, and maybe even race with your friends. Try and make it a fair test, and then stopwatch several of your friends or your family doing a race and find out what your average speed was. So this whole lesson is about knowing the difference between speed and velocity, and also calculating speed and velocity. So we should know now the difference is speed is simply a measure of how fast something is going, and velocity is exactly the same, but we just happen to know that little bit more information about it, which is the direction it is going in. Now I'm going to just briefly touch on this because I can't help myself. In physics, we have two things called vectors and scalars. A scalar is when we know one piece of information, one number, one value in our results. And a vector, you might recognize it from Despicable Me. He calls himself Vector. Have a little watch of, so maybe YouTube vector, and he might come up with it for a nice little explanation for you. But a vector is something with two quantities. So we know two pieces of information for our results, and these are really good examples of the differences between the two. I'm going to go into it in a lot more detail later, so don't worry too much about it now. But speed is a scalar because we only know one piece of information. We know how fast it's going, miles per hour, meters per second, whatever. The velocity, we know two pieces of information, so it's a vector. We know the speed, miles per hour, minutes per second, and we also know the direction that it's going in, which could be, angles, for example. So we need to know the difference, but I do want to kind of stress that the words are used one and the same. And even in your exam, they're used one and the same. Sometimes you do think, why did you write speed there when you should have written velocity? But they're often written as if they equal the same. And as far as that formula is concerned, they do. So you've been working out the speed using the speed, distance, time triangle. But if you want to work out velocity, it is exactly the same. The S for speed is replaced with a V for velocity. So if you see S equals d over, or a line t, that's speed equals distance divided by time. Velocity, exactly the same. Velocity equals distance divided by time. Okay. Now, if we look at the picture on the right, I can just remind you how to use it in the triangle form. You cover with your hand what you want to find out. So you would cover velocity, or you would cover speed, and then you can work out how you would find that out. So if I cover speed with my hand, I would be left with distance over time, distance divided by time. Similarly, if I wanted to find out the time, I would cover up time with my hand and I would be left with distance divided by speed. Same would apply to velocity. If a question asked me to work out the velocity and it gave me the time and the distance, I can still use the speed equals distance time triangle. It's absolutely fine to use that. You can use them exactly the same. So essentially, with that triangle and with that formula, you've just been able to answer two types of questions now. You can calculate the velocity and you can calculate the speed. Now, obviously, you're not going to be able to calculate all the velocity because there are two parts to velocity. It's a vector. You're not going to be able to write down the direction unless it tells you, but you are going to be able to write down the speed aspect of velocity using this, and they will never ask you for anything other than this for the exam, so that's all you need to worry about. We're going to do a little learning check now and put some of your knowledge into action. And we're going to have another race. It's going to be a Formula 1 race this time. No cars though. It's going to be Superman versus Quicksilver from X-Men. Now, I thought Quicksilver was faster than he is, but he obviously isn't, because after researching this, I found that his top speed is a mere 9,151 miles per hour compared to Superman's 7,200,000 miles per hour. So it's not really much of a race because we know Superman's going to win, but we can work out what their speed would be, or their time would be, sorry, because we already know the speed, to complete the Formula 1 racetrack. So the Formula 1 racetrack I've chosen is Monaco, and it is 2.074 miles long. So the track's distance, the distance of the race, is 2.074 miles long. And we have the top speeds, and that is also in miles, so miles per hour, and the distance is in miles. So both units are the same, so that's great. So we're going to work out the time that's going to come out of this. Now remember, units, 2.074 miles, 7,200,000 miles per hour. When we plug that into our little triangle, the result we're going to get for time is going to be in hours, because what went in is hours, so what comes out will be hours. So we look at our triangle, and we're not working out average speed, we're working out time. So we would cover up time, and what we're left with is distance divided by speed. It can be a slash to show divide, or it can look more like a fraction and be a horizontal line and the two letters on top of each other. Okay, so we're going to find out how fast, the time it would take for Superman and Quicksilver to get around the Monaco Formula 1 racetrack. In this example, as I just said, we use the triangle, we cover up time, and we're left with distance divided by speed. Okay, so we know that the distance is 2.074 miles. That is the total distance of the Monaco Formula 1 racetrack. We'll do Superman first, and we know his speed is 7,200,000 miles per hour. We plug that into the formula. We have distance divided by speed, 2.074 divided by 7,200,000, and we come up with this tiny little number, 0.000000288. That's how many hours it would take him to go around. That's a bit of a useless number, so we're going to convert that to seconds. So it makes it I don't know, slightly more easy to understand. Now, there are 3,600 seconds in an hour. Okay, you can just Google that if you want to, or you can work it out manually because you know how many seconds are in an hour. So we do the time it took him in hours, we multiply it by 3,600, and we're going to get 0.0010368. That is the time in seconds that it would take Superman to complete one lap of the Formula One racetrack Monaco. We can do exactly the same for Quicksilver. We know the distance of the track and we know his speed is 9,151. That makes it 0.0002266 hours. Multiply it by 3,600 and we get his time in seconds as 0.81576. Now, I wouldn't worry too much if you can't work out, you can't convert hours to seconds off the top of your head, you know, working it out manually on pen and paper, possibly with a calculator, which you are allowed in these exams, I might add. You are always allowed a calculator. I wouldn't worry too much. If you were really reaching for those top marks, I would probably memorize 3,600 as a number, just because you don't have a lot of time to answer questions in exams, and you might be asked to convert hours into seconds. It's unlikely, but you might. And if you really want those top marks, and they're so difficult to attain now with these levels that they've put in, I'd probably just spend a few minutes memorizing the number 3,600. So to convert hours into seconds, you multiply by 3,600. Anyway, Superman we knew would be the winner. We knew that from his ridiculous top speed in the millions. But there you go. It takes nearly a second for Quicksilver to complete the lap, but Superman's already having his fish and chips at the other end. I want to put some of this into action, into some sort of word questions that you might be asked for your iGCSE. These are more than possible that you'll be asked something like this, and the only way you can really prepare is to practice. Just keep doing questions and making sure that you can do them quite quickly. So I have given you 3 questions, and I would like you to answer them all. Pause the video, give it a go, and we will go through all the answers together. The 3rd question does require you to fill in a table. Just remember that you are going to need your units in there, and your units should always be at the top of the table. You see I've written time in seconds. Your average speed should also be put in brackets as well. You don't repeat the unit in every single box. You don't write 5 seconds, 4 seconds, 7 seconds. You always write it in the top of the table. So they're going to expect you to know how to write a table, and that's the first thing you really need to take in regarding tables. Okay, I hope you've had a chance to go through these questions. If you haven't, and you haven't paused, please rewind a little bit. Try not to look at the question answers, sorry, and have a go, because it really is important to practice. So the first question, we wanted to know, work out the time. We wanted to know if the time was under 20 minutes. So we get our little triangle for the speed, distance, time formula, and we cover T, cover time, and that leaves us with distance divided by speed. We were given those 2 things. The distance was 13 miles and the speed was 90 miles per hour. So we plug them in and we get 13 divided by 90. And that gives us the time 0.14 hours. Remember, hours went in, 90 miles per hour, so hours are going to come out. I've converted this to minutes because the question asked, are we under 20 minutes? Is it 20 minutes to get to the next station? So we need to convert it to minutes. I know it's difficult converting units. This is why people still, get it wrong years later. Do try to practice converting between them. It can waste time in an exam and it can lose you marks. But I do understand it's difficult. But yeah, please just keep practicing at it, especially if you want the top marks. So we want to convert it into minutes. There are 60 minutes in an hour. So we multiply 0.14 by 60. And this means that the train takes 8.4 minutes to reach the next station. And yes, we are well within the 20-minute time limit that was set. So yes, we make it on time. Question 2. Is it over 30 miles an hour? Is the car travelling over 30 miles an hour? Okay, so we need to know speed, miles per hour. We cover up speed on our triangle and we're left with distance divided by time. We were given the two numbers. It was 2.2 miles divided by 0.05 hours. So the speed was 44 miles per hour. We don't need to change any units. That's exactly what we wanted to get from it. But yeah, we were going over the speed limit. The car was going over the speed limit at 44 miles per hour. In the final one, where you had to fill in the table, this was a race between you and your friends. You knew that the garden was 30 meters long, and we could presume from that that the race was 30 meters because we were given no extra information. So the distance was 30 meters. We knew that the time it took was 5 seconds for you, 4 seconds for Lily, and 7 seconds for Tommy. So we knew time and we knew distance. We needed to work out the speed, or the average speed. So we just plugged it in. Speed equals distance divided by time. So for you, it was 30 meters divided by 5 seconds, and the answer was 6. It was 30 meters and 5 seconds. So the units that are going to come out of there are meters per second, which is the one that most physics exams work to. Similarly for Lily, it's 30 divided by 4, gave us 7.5 meters per second, and Tommy was 30 divided by 7, which gave us 4.3 meters per second. Remember, in the table, if it asks you to fill out a table, put the units in the top row. Don't keep repeating them when you're in the table. So we could work out that the Lily won the race. Her average speed was the highest by quite a significant amount. The whole point of this video is to do a speed versus speed and velocity test, Ironman versus Rainbow Dash. So this is what we're going to do now with all of the knowledge that we've acquired on how to work out your speed and velocity. We need to know some stats before we start so we can do the maths. We can work out who's going to win in this competition. So Rainbow Dash, she is a My Little Pony. She can travel 5 times the speed of sound. That's not bad. Upon entering this, upon breaking Mach 5, she enters hypersonic speeds and actually creates a sonic rain boom. This doubles her speed immediately to Mach 10 and creates a lovely rainbow as she does it. So we know what Mach 10 is. So her top speed is 7,600 miles per hour. I think they presume that the average speed is 5 times the speed of sound, so that's about 3,800 miles per hour. So she's got a top speed of 7,500 miles per hour approximately. Comparing this to Ironman, his top speed, we have to hypothesize a little bit on this, and what I mean by that is we have to kind of make an educated guess. Is his top speed is about 1,672.5 miles per hour. And we know this because he can fly alongside fighter jets, and at one point he does accelerate past them. So he can be a little bit faster than a fighter jet. So a fighter jet generally, I mean, they're all a little bit different, but flies around 2.1. So we can possibly up that a little bit to approximately 2.8 Mach, which is 2,148.35 miles per hour. So we're assuming, we're making an educated guess, we're hypothesizing that Ironman has a top speed of Mach 2.8. Okay. If you want to know where I calculated these numbers from, you can look at the extra video which is underneath this, called How Fast is the MCU Ironman. It's really quite fun, and I really recommend you reading it and watching it, sorry, because it will, you should be able to understand how all the maths is calculated throughout. From working out these numbers, we can pretty much say outright that Rainbow Dash is going to beat Iron Man in any race because her top speed is 7,600 miles per hour compared to his quite measly 2,148.35 miles per hour. But if they were going to go on a race, we would like to see how quick what time they would do this in. So I've chosen London to New York. And lo and behold, London to New York is 2,148.35 miles away. I was quite shocked when I randomly chose this race, and if you notice actually, the time top speed for Iron Man is 2,148.35 miles per hour, and the distance from London to New York is 2,148.35, which was a really random occurrence, but there you go. So we need to work out the time that it takes to travel this distance for both of our contestants. We know their speed, we now know the distance because I've just given it to you, so we can work out the time it took them to do it in. So time equals distance divided by speed. If we do Iron Man once, it's quite a neat calculation just by random. His distance we're travelling is 2,148.35 miles and his top speed is 2,148.35. So we divide them by each other and we get 1 hour. So it would take Iron Man about 1 hour to get to from London to New York. Rainbow Dash, again, we want to find out the time it takes her to do this in, which is distance divided by speed. The distance is 2,148.35 miles and her top speed is 7,600. So we divide them together and the time is 0.28 hours. I want to convert that to minutes because that's a bit of a funny one, 0.28 hours. So I times it by 60 because there are 60 minutes in an hour. 0.28 times 60 is 16.8 minutes. So Rainbow Dash travels from London to New York in 16.8 minutes. I know it can be quite difficult to hear numbers said out to you really fast, so just pause and look through and digest what's going on and what I've done to reach those figures. If you've watched some of the other trials, you'll know by now that every single lesson we have an exam summary sheet. I recommend that you print this off and you store it and you collect them up each lesson because they contain absolutely everything that you will need to pass your iGCSE. I could just throw this at you every time and not even bother with the rest of the lesson, the rest of the assignments, but the rest of it is there to hopefully make you understand it a lot better and to give you a chance to practice it so that you put it into some long-term memory. But everything you could need from this lesson, from these assignments, is contained in this exam summary sheet. Put it to one side, store it, put it in a pile with all the others, and when we come to revision, you can use them as really good resources for learning what you actually really need, and also maybe as flashcards. After the exam summary sheet, I will always go through practice exam questions. Practicing exam questions is crucial. If you've looked at the other trial lessons, you'll have heard me say this quite a few times now. If you want to get a good mark, you need to practice exam questions. You can learn all of the content and still not do that well because of the way things are worded or the way things are represented or asked in a slightly bizarre or unusual way. And you really need to learn how the exam board is going to deliver questions to you, and the only way you're going to do that is through practicing them. So we go through them together, and then I'll also put some in the assignment sheets. If there are none in the assignment sheets, it means that we've gone through them all together in the lesson. That's possibly a good thing because it means that the material is not tested on often, but if you're looking for those top marks, that's, you know, you still need to direct some attention there. So have a go at these practice exam questions. You should be able to do them. Pause the video because in a second I'm going to go through them together now. I hope you had a chance to go through the questions and you didn't find them too difficult.
I did pick a particularly bad one that I think illustrates my point sometimes about units and about reading questions. So the first one is essentially that experiment that we went through with the car on the ramp. But as I said, they do shake it up. They don't often put it in that form, and this one's done exactly that. It's not a car, it's a sort of glider on an air track holding up a piece of card. So the gliders moving through these light gates, we were familiar with them sensors that recognize the time that the glider goes through. You need to know what the light gates are. They're connected to a data logger, it's mentioned that. And as the card passes through them, it records the time that it passed through. And the first question is, state the relationship between average speed, distance moved, and time taken. Well, to be honest, you didn't really need to read any of that question to answer that. It's average speed equals distance divided by time. They were just asking you for the formula. You could have written it the way I've written it, or you could have written it S equals D divided by T, and you could have written the divide like a slash like I have, or probably better, a fraction type slash, a horizontal line. So it would have been S equals D divided by T. The next question says calculate the average speed of the card as it passes through the light gate. So if you haven't remembered the S equals D divided by T, then you're not going to be able to calculate this. The question is really weird. It doesn't read very well. It doesn't read very well to me. And my point is, if they've given you two numbers and they're asking you for the other one in the formula, so in this case they've asked you for speed and they have given you a distance and they have given you a time, even if it doesn't really make sense and the question is really quite poorly written, if they've given you the distance and they've given you the time, then use them. If they've only given you two numbers to work with, forget how they've written it, just plug them in and work it out. So they've asked for average speed, they've given you a distance, they've given you a time, so you work it out. Average speed equals distance divided by time. Now, I said the majority of the questions in your exam will ask you it to be written in meters per second, m/s. That is still the case, but you must read questions because this one gave you the units that it wants it in. It gave you centimeters per second, cm/s. So it wanted you to calculate the average speed and give it in centimeters per second. Okay, read the units. If you didn't write centimeters per second, you would have lost 2 marks because your workings would have been wrong and your answer would have been wrong. And that brings me to the marking system. You can see that this is worth 2 marks because there's a 2 in brackets. 1 mark is for the working out and 1 mark is for the result. So to get it into centimeters per second, what goes in must come out. So we already have centimeters sorted, 8.3 centimeters, but we've got 314 milliseconds. So we needed to convert that into seconds. So if we did that, we were left with 8.3 divided by 0.314. Check out my video on converting units if you're still struggling with converting milliseconds to seconds, minutes to hours, etc. And if you'd done that, you would have got 26 centimeters per second. So when in doubt, do meters per second, but always, always, always look for the units, because if it gives you something else, then they're expecting you to give that and that alone. Okay, next question. The average velocity of the toy car is given by, remember the speed equals distance time formula, the speed equals distance time triangle, the same applies to average velocity. It's the same triangle, you just replace the S with a V. So if we were trying to work out the average speed, it was distance divided by time, and therefore if we want to work out the average velocity, it is also distance divided by time. So that's B. And then finally, the last question is state the equation linking average speed, distance moved, and time taken.
it's just another way of writing the first question. They wanted you to give the formula, and you can write it in the 3 ways that I've mentioned there, and only write one. There's not a lot of time in exams. They say it's about a mark per minute. That is slowly changing, and it's getting worse. So don't waste time. Just write one of them. Don't repeat them. Well done. That was a seriously long lesson. That's slightly longer than a lesson would normally be, but I hope that it went in, and I hope you know a little bit more about how formulas in physics work, and you can apply that one to questions. Every week you complete this at your leisure, and then hopefully you're in a really good position now to complete some of the assignments. Submit them by next Friday at 6 p.m. In the meantime, check Twitter, check Facebook. I constantly put up tips and videos and articles and activities that are related to the week's work. Some of it should be able to put it into some long-term memory for you, and others would just be for interest if you happen to have found this topic more interesting. And then if you have any questions or you're struggling, please do go to the Facebook group, please go to the forum, ask me, ask your fellow students for help. Don't put it off. Get it sorted the minute that you feel you have a problem. But well done, you've got through it, and I'll speak to you next week.